board, and I want you to be thinking, man, bio. Anyway, what does bio mean? That's life. So it's basically going to be the molecules of life. Now, if I asked you guys, what do you think would be some molecules of life? What things start jumping out to you? Well, hopefully you should think water. You might think oxygen. You might think carbon dioxide. And if you're really, really smart, which that probably isn't many of you, then you might think about glucose. That would be C6H12O6. And that's only if you're elite, right? If you're average, normal, you probably wouldn't have thought about that. But if you are really elite or great, then you would have thought about that. And speaking of being great, man, I got a question for you. What makes you great? If somebody was to ask you, what makes you great? What would your answer be? If you don't have an answer, what does that mean? You're not great. I have several answers. I don't know what you would be, but I want y'all to think about that, man. If somebody asks you why you're great, you need to have some type of honest answer, don't you? And if you don't have one, you need to be working on it. All right, so vocabulary that you're going to learn. You're going to learn what an organic molecule is. Then these things we will learn monomer and polymer. Does anybody know what the prefix mono means? It actually means one. Does anybody know what the prefix poly means? It means many. This is like math terms, right? And if you know that a monomer means one, then a monomer will be considered to be a subunit. Now, we will have biomolecules that we will talk about today, and there's only two biomolecules that we will discuss. Those two biomolecules are going to be carbohydrates and lipids. Now, for each molecule we discuss today, you will need to know their subunit, which for carbohydrates, it is a monosaccharide, and that would be the monomer, right? A monomer and a monosaccharide is basically the same thing. And then once you put a bunch of monomers together, you can make a polymer, which would be a polysaccharide. So big little bit of information we need to be familiar with there. So let's go ahead and start with this thing, man. The role of carbon in organisms. Carbon is considered to be an organic molecule. And just FYI, it is any molecule that contains carbon. So if there's any molecule that contains carbon, it'll be an organic molecule. That would include CO2, because it's carbon dioxide, or C6H12O6, which is sugar. You do kind of need to know how these images would look, man. If you got this image on an EOC, would you be able to identify that this is C6H12O6? Well, one easy way to identify glucose is if you ever see a ring structure, like you see right here, that typically means it's glucose. Another easy way to identify it is you can just simply count. 1, 2, 3, 4, 5, 6. That tells you that it's C6. Then if I did H's, that's 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the chemical formula would be H12. You might want to take a wild guess what the O's would be? It'd be 6, right? What do you notice about these molecules, C6H12O6? What's funky about that? 6, 12, 6. That's 6 plus 6 is 12. There's some kind of connection there, ain't there? Something's going on, and you'll see about that in just a second. All right, so anyway, carbon, right, since it is organic, it's easy to find in nature. There's another feature that allows carbon to be special, and it's the fact that it can form a variety of bonds. But let me make this note real quick too. You also need to know that all living things are composed of the following main elements. You do need to know those main elements are carbon, hydrogen, oxygen, nitrogen, phosphorus, and sulfur. And y'all ever heard of the word chomp before? Like chomp, like you chew something, like a Pac-Man chomps. You know, this is going to sound weird. Pac-Man chomps the little white balls. God, that sounds awkward, don't it? Okay, but that's what he does. He goes around flying around. That's what he does. But if you'll take out that M and put an N for nitrogen and an S, that'll help you remember the elements that we're actually going to be talking about. Okay. The only two, just FYI, lipids and carbohydrates only have these three, right? We won't even actually discuss nitrogen, phosphorus, or sulfur today. Now, carbons is neat because it can form a variety of bonds. It can form straight chains, branch chains, or rings. This would be like a straight chain. This could be a branch chain, this one right here. but the big one is rings, and a big example of a ring structure in carbon or with carbon is glucose. All right, you ever built a Lego house before? Anybody ever built a Lego castle, something like that? Each Lego, I want you to remember, each Lego, if I just have one Lego, that would be a monomer. All right, so every block is a monomer. If I had a whole castle, that would be a polymer, right? So remember that a mono is made up of one and a polymer is made up of many. Another way to look at it would be to say each one of these blocks would be a monomer, right? When you put a bunch of blocks together, and it doesn't matter how many there are, right? There's 3 here, there's 5 here, but both of them are still considered to be what? A polymer. They're just made up of a different number of monomers. This long chain, what do you think that long chain would be? Polymer. Each individual thing is a monomer. Does that make sense? Here's some even crazier stuff. Starch is a polymer. But when you break starch down, this is like a potato, just in case any of y'all know baked potatoes and stuff like that. But when you break starch down, it turns into these things. Does anybody know what, when you break starch down, what it turns into? It actually turns into glucose, which is sugar. This is why people who have diabetes cannot eat foods that are high in starch, because when their body digests it, it all ends up turning into what? Glucose, which is sugar. So that's why somebody that has diabetes cannot eat heavy foods or heavy starches like rices, pastas, potatoes, things like that. All right, so now carbohydrates. This is going to be the first biomolecule we talk about, and everything is in the word. Now I want you to look at this. If I say carbo, what element does that tell you is in it? There you go. If I say hydrate, when I say hydrate, what should you think about? So there's H2O, right? So now if there's not a number, that means it's an understood one. Is that correct? So what type of ratio does it look like carbohydrates will be in? 1 to 2 to 1. Do y'all see that? For every 1 carbon, there will be how many hydrogen? And for every 1 carbon, there will be, so it might be something like C11, H22, O11. Would that be a carbohydrate? Absolutely. Right? What about C5H, right? H10O5. Would that be a carbohydrate? Is that 1 to 2 to 1? Yeah, it is. For every 1 carbon. This is a 5. This is a 5. Does that help some of y'all out? It's C5H10O5. My handwriting was terrible. I apologize. What about this? What about if it was C7H14O7? Would that be a carbohydrate? Absolutely. All right, now, but the main example you will hear about in this class is C6H12O6, and it is glucose. And it includes breads, rice, grains, and obviously a lot of things that people with diabetes can't eat. Now, carbohydrates, 2 main things we need to be aware of, right? What are the monomers, right? The polymer is a carbohydrate. So what are the monomers, or the building blocks, right? The building blocks, also known as the subunits. The building blocks or subunits of carbohydrates are these things called monomers, simple sugars, or also a monosaccharide. Those 3 things all mean the same thing. And the main example that you need to be aware of is what? What's it say? Glucose. Jesus, why do people call me like I don't teach, like I don't do anything all day long? Hello? Doing good. Yeah, I sure shall. All right. Tyler, you've been out of school too many days, baby. Yeah, I got to go see Miss, what's her name? Oh, God. What's the lady's name? The social worker, Miss Hargrove. You know where she's at, don't you? Okay, it's right across the hall from Suggs' office. Just go to the main office and ask where Miss Hargrove's office is, okay? They'll sort you out. All right, we're ready. Can I move on, guys? All right, so 2 things you definitely need to be aware of is what's the building blocks and what's the functions. Okay, so the building block of a carbohydrate is a monomer, simple sugar monosaccharide. It's all the same word. It's like producer autotroph. It means the same stuff, right? But the real example of it is this glucose, okay? Now, you can take a bunch of monomers, right? A bunch of glucose molecules. So there's all these glucose molecules. Y'all see that? There's all those little glucose molecules. But if I start to combine them, right, making a long chain, making it a polymer, then I can form something called a what? Polysaccharide, right? And these are things that are made of many monosaccharides. Now, there are three that you need to be familiar with: starch, glycogen, and cellulose. And they are very easy to remember. When I think of starch, I think about a potato. Can y'all do that? Can y'all think about a potato when you think about starches and rice and wheat? Do those things come from animals or do they come from plants? Okay, so keep that in mind. If you know starch is something that comes from plants, then that tells you that that's energy storage in what? In plants. If starch is for plants, then that must mean glycogen must be energy storage in what? In humans. That's the easy way to remember that. Now, the last one you've got left is something called cellulose. And the way you remember that is you remember the first part of cell, and that tells you that it's a major part of a plant's cell wall, right? So if you can remember cellulose, then you'll remember it's a major part of a plant cell wall, okay? Nice and easy. So you got your monosaccharides, and then you got your polysaccharides. This is some examples of what they look like. Obviously, they look different based off how these things combine. But at the end of the day, take a look at this, man. Each one of these little things, like starch, right here, each one of these little ring structures, each one of those is a molecule of glucose. And ironically, by the way, this looks extremely weird, the ones that I just decided to to color in there. That looks terribly wrong. Does anybody else, Quail, you see that? Is I need to like go further down just to get that out of frame, don't I? There we go. Here's what's crazy about this stuff. If each one of these things is a glucose molecule, when I eat sugar, I think it tastes sweet, right? But if you eat a baked potato, what does it not taste? Does not taste sweet, which is kind of strange to me, but that's how chemistry works. It changes the property of things, and sometimes it's not always going to taste like what it's made of, which is very, very strange. All right, now there is a function. You do need to know the function of what glucose is and what it does in the body. It provides the cell with an immediate source of energy. And there is this test that you can use to test for the presence of a polysaccharide, specifically starch. And that test is called an iodine test. And you need to know if it turns basically a black or a purple color, then that means that would be a positive result for the presence of starch. If it stays a reddish color, then what that means is that is a negative result. This is what it would actually look like, right? When you put iodine in water, it just typically has this reddish tint to it, like this over here. That's just typical iodine in water. But what they did was they dissolved a couple of things in water: starch, milk, tofu, and apple. And then they added iodine to it, just that reddish color. And you can actually see that it changed colors right there. And obviously that would be a positive result. Milk does not have any starches in it. Tofu does not have any starches. You could say apple had a little bit because you have a little discoloration, but obviously this one would be the one that will starch, has a very clear positive result. All right. Now your next ones, okay, you've got carbohydrates out of the way. Now you've got to hit these lipids. Okay, lipids are going to be very similar to carbohydrates. They do contain carbon, hydrogen, and oxygen, right? But the big key here is that they are not in a 1 to 2 to 1 ratio. So something like C5H22O11 would classify as a carbohydrate. Some examples of these things, carbohydrates, is fats, oils, waxes, butter, and anything that's greasy. Something that will show up on the EOC is whale blubber. And a whale blubber is asked in a question about them having long-term energy storage because they swim great distances, right? And what do y'all know about deep levels in the ocean? Is it warm or is it cold? It's cold. So they have to have this whale blubber to have insulation, right? So be aware of that. Just FYI too, when you eat a bunch of carbohydrates like breads, pastas, and all that stuff, how does your body store that energy? In the form of what? Fat. So your body will get fatter. And that's how you store long-term energy. So that's why for you to burn fat, just FYI, for you to burn fat, can you just go to the gym for like 15, 20 minutes and work out? No, because what you're burning is you're only burning your carbohydrates, your glucose. You have to burn all that energy before you will start to burn your fat cells. Just FYI. So if you're one of those people who comes to the track, I see one in here today, looks like they might be one who comes to the track and runs 4 laps and says, I'm tired. I see one looks like they might be that kind of person. But that's not going to burn those fat cells. No, that's right. That's not going to burn those fat cells. Well, how many times you got to run around that track? You think maybe 8, 9, 10 times? Yeah, at least 10 before it starts burning fat cells. So just be aware of that, man. All right, one is immediate energy. That's glucose. Well, one is long-term energy. Which, you know what's funny? I never could figure out why they give the football team pastas prior to a football match, because you're not going to digest that sugar that quick and have any of that energy available. But I'm not one to educate someone who knows it all already. So, it's hard enough trying to teach children because they think they know it all. It's worse when you try to teach an adult something. Have y'all ever tried to teach an adult something? Doesn't work too well, does it? They just pretty much tell you to shut up. You don't know anything, right? So anyway, well, it's kind of the same when adults try to teach children. Anyway, all right, lipids. All right, you do need to know the building blocks. If you'll kind of remember the letter E, right? If you ever see any molecule that looks like the letter E, then you'll be able to identify this lipid. And it basically looks like that. Okay, so if you see this part, the red part is actually going to be called your glycerol backbone. You can see me drawing it here. Right, there's a glycerol backbone right there. And then each backbone will have 3 fatty acid tails, which are just 3 carbon and hydrogen chains, just long chains. You can see them right here. Right, there it is right there. There's 3 tails with that, glycerol backbone. This is what makes up, a lipid. And that's pretty much all it is. So if you see something that looks like a E, then most likely it's a lipid. If you see something that looks like a ring structure, for example, like this one right here on the EOC, then most likely it would be a carbohydrate. Now, just like a lipid has a test, or excuse me, just like a carbohydrate has a test, lipids also have a test that will test for the presence of a lipid. It is called the brown paper bag test. If it leaves a shiny spot, then lipids were present. Many of y'all have probably had potato chips or pizza on top of something that was brown, like a cardboard or whatever, before, and it left the shiny spot. All that means is that most likely it was cooked with fats, oils, things like that. Does that make sense? So greasy things are going to leave that greasy spot. That tells you it's a lipid. And I'll tell you another word that'll help you figure out if it is a lipid. If it is insoluble in water, right, then that should be a dead giveaway that it is something that is most likely going to be a lipid. What does insoluble mean? Do y'all remember? That it will not dissolve in what? What if it will dissolve in water? Would it be a carbohydrate or a lipid? Most likely a carbohydrate, wouldn't it? Will starch dissolve in water? Yeah. Will sugar dissolve in water? Yeah. So most likely if it's soluble, it'll be a carbohydrate. If it's insoluble, it'll most likely be a lipid. All right. So here you got cooking oils, you got butter, which I was cooking with butter yesterday. Soap, I wasn't cooking with soap. And triglycerides. These are things that actually determine your cholesterol level. Have you ever heard of people having purple? Have you ever heard of people having high cholesterol? If they have high triglycerides, then that means they're eating a bunch of what type of foods? Fatty foods that have most likely been cooked in what? Oil, right? Man, some of y'all probably eat fried pork chops, fried chicken, right? Some of y'all probably eat fried butter, don't you? Any y'all ever had fried butter? Y'all know it's a real thing? Fried butter? What about fried mozzarella cheese? You ever had that before? People love to fry stuff in the South, don't they? All right? So listen, man, you have to be able to compare these things. Two things I told y'all that will always be important is the subunit, the building block, or the function, right? So when it comes to a carbohydrate, the monomer, just FYI, that's what it's asking for when it's asking for the subunit or building block, is a monosaccharide. Specifically, that monosaccharide is C6H12O6, which is glucose. Now, what is that glucose used for? Is it long-term energy or immediate energy? It's immediate energy. And it's short-term energy storage. Which one is long-term energy storage? That would be your lipids. It can also be used for insulation because it's in the form of fat cells. And remember, the building block is the glycerol backbone. And how many fatty acid chains? There's 3. Does that make sense to y'all? All right, you need to know what these things are built of and what they're made of, what the building block is, and how they come together. Let's go back over these vocab one time and see if I got this left-hand side now. Organic molecule is anything that contains what element? Contains carbon. Now, a monomer is the building block of something. A monomer is the subunit. Those are the same words. So the monomer of a carbohydrate is a monosaccharide. The monomer of a lipid is the glycerol, and then the 3 fatty acid chains. Now, if you put a bunch of monomers together or a bunch of subunits together, you'll get the polymers. The polymers of a carbohydrate could have been polysaccharides, and there were 3 of them. It was starch, glycogen, and cellulose. The polymers of a lipid would be the lipid itself, and it would be fats, oils, waxes, butters, things like that. Okay, so you need to know what carbohydrates would obviously be an immediate source of energy. Lipids would be long-term energy, and then obviously insulation. Okay.